website, acce.in. Under there is a menu say events, and then I think under events we have webinar. If you go and click on the webinar, we have all the webinars conducted by ACCE, especially starting from the first day. All 10 talks are available under that webinar. Number 2 is we also have the ACCE Bangalore YouTube channel, and if you Google search or under YouTube, you can search ACCEI Bangalore. You will also get on the YouTube channel. This is completely a dedicated channel on the YouTube. You will also find all the ACCE webinars which have been happening since recent times. You will be able to find. So the third thing is the PPT. On the YouTube, we will have a live program. And then on the third platform is the SlideShare, where all these PPT programs, all the PowerPoint presentation slides will be available to you. So these are 3 platforms where we have been, the presentations will be made available to you. I will not take much time. I thank all the speakers who have consented to be a part of this wonderful series. I'm sure all the participants will be immensely benefited, and I would like to say this to the participants, many, and especially those who are from the students community and then who are new to the association with ACCE. All these speakers who are being sharing their knowledge with you people, they're all extremely busy and then extremely reputed. Probably many of them are internationally reputed also. And I would like to end with this brief talk about the series. I would like to end this, and I would also like to say that 4th March is again the World Engineering Day, which is going to fall on the which will fall in between. That's the reason I would like to congratulate you, and once again in advance for the World Engineering Day. And I wish the program and all the participants a great success. Make use of this wonderful opportunity, and I'm sure you're going to get benefited. Thank you very much, and the floor is back to you, Rangnath.
Yeah. Thank you, Dr. Agnes. Now I request our President, Dr. M.U. Ashwath, to give his presidential address on this inauguration. Dr. Ashwath.
Good evening, Program Leader Ajit, Dr. Ajit Sabnis, and Program Coordinator Rangnath, and all the other participants, especially our past President P. Suri Prakash, who took the first advantage of coming online and live through a series of lectures. As soon as the pandemic started its activity, Suri Prakash also started his activities, and it was a grand success. The 2 series, I think he has carried almost 2 months. He has carried the activities. It was a grand success. And later on, many other organizations and individuals took the benefit of the online platforms, and we at ACCE also took some interest and created knowledge dissemination activities very seriously. And as all of you know, under the working groups, one of the most active working group is ACCI Institutes, headed by Dr. Ajit Sabnis. So they have already completed 1 series, Sustainable Engineering series, and this is the 2nd series after the successful feedback from the first series. And this is the need of the hour, and also it was requested by many as the feedback from the first series, and motivated the ACCI, especially the institutes group, to carry on this. And if you see the experts on this engineering series or structural engineering series also, all of them have 20 plus years of experience, and it is highly difficult to get such expertise freely available to all the people, and it is free and through ACCI. And I'm sure through this series, it will create definitely some focus and interest among the participants, especially the student community, they are participating, and even the engineering professional colleagues for clarifying their small issues and doubts if they have through the interactive discussions. I was told by Ajit Sabnis that instead of 45 minutes, it was increased to 1.5 hours now, the session. Presentation and discussion with the expert. So it is definitely going to make a lot of impact on the profession itself by interacting with all the experts. And I wish the program a grand success. And definitely ACCI institutes will make a mark in the days to come, in the months to come, and in the years to come. And it will definitely grow as an institute itself by catering to the needs of the professional practicing engineers as well as the student and the faculty academia is concerned. And this is a beginning, and the beginning is made very successfully. And as it is said, the well begun is full complete. So I'm sure it's going to be a major activity of ACCE in the days to come. And I'm sure the other working groups will also follow suit and conduct many activities in the similar lines. As Ajit was mentioning, World Engineers Day is also coming up, and if possible, in one of the sessions, maybe we can have a few minutes discussing on the need of the hour, need of the engineers on the occasion of World Engineers Day and discuss. In fact, other professional bodies like the CEI is also conducting an exclusive panel discussion on World Engineers Day. Thank you very much, Coordinator Ranganath and Dr. Ajit Sabnis for taking initiative, and I compliment and congratulate you for this effort, and I'm sure your efforts will be utilized by all the community people. Thank you very much.
Thank you, sir.
Thank you, Mr. President. May I now request our Vice President, South, Mr. Tamil Selvan, to kindly propose vote of thanks for this short and sweet inaugural function. Mr. Tamil Selvan.
Thank you, Engineer Ranganath sir. Lord President, Program Leader Dr. Ajit Sabnis, all past presidents, honorable founder members, and all other dignitaries, members, delegates, and guests. A very good evening to one and all. It is so wonderful to see you all here in this forum. To adapt to the situation of COVID and to pursue the ACCI vision, ACCI Institute's work series as webinar. If you look beyond the surface and key intellectual, understand that it is one of a lifetime opportunity. Like distinguished members of the forum and delegates started as celebrated by our program leader this structural engineering series with the first presentation by Engineer Surya Prakash ji, very well known eminent structural expert from the industry are in line to give a great presentations to all of us. I assure you, if you learn to benefit, then your life will never remain. The skill or upgrade knowledge essential today, and this group is helping us to excellently pursue this. I hope that this series will inspire ideas and discussions around the ways that we can make our society a better place, and we can move another step forward with a constructive attitude and more open-minded. I wish this institute group will develop from this level to another form, which is almost like a distance education concept in future. Coming to the part of you, I would like to thank wholeheartedly our President Dr. Ashwath for creating this idea and group. Also, I want to express my heartfelt gratitude to Dr. Ajit Sabnis and Sri D. Ranganath for excellently developing the idea, and to their team of motivated and dedicated members. I must mention our deep sense of appreciation to the speaker of the day, Engineer Surya Prakash, and all other speakers, Engineer C.J. Raghu, Engineer C.N. Yadunandan, Engineer B.V. Ravindranath, Engineer Chandrasekhar, Engineer G.H. Basavaraj, Engineer Raipure, our VP West, Engineer Heman Vadalkar, Engineer Suresh Rao, and Engineer N. Nagendra Kumar. Thank you all. I wish to express our gratitude to Engineer Rajesh Kannan, Secretary General, for his tireless efforts for this event. I am also grateful to the delegates for registering. Finally, I would like to take this opportunity to place on record our hearty thanks to Sri Anne Gowda, Ms. Diksha,
Okay, I think it got cut. Okay, thank you very much, Mr. Tamil Selvan. That was very nice of you. Friends, I think now we are going to start our series on structural engineering. We'll begin now. Very good evening, friends. Warm greetings to you all from the Association of Consulting Civil Engineers India, ACCEI. Civil engineering, aptly referred to as mother of all engineering, is a profession that contributes substantially towards a safe, healthy, and prosperous societal living. Structural engineering, one of the key disciplines of civil engineering, is the most important and responsible group of professionals that create safe and optimal facilities for effective usage by the society at large. One of the main objectives of ACCEI is to create awareness amongst the civil engineering community regarding the technological advances being made in the respective fields and update the professional knowledge among the practicing engineers. As was conveyed during the inaugural session by our president, ACCEI has formed 9 working groups within the association forum in order to protect the rights and interests of civil engineers in particular and the society at large. We are happy to inform that one of the working groups, ACCEI Institute's working group, headed by our Dr. Ajit Sabnis, has been very active in its task of awareness creation amongst all on the various topics of civil engineering. Recently, the ACCEI Institute Working Group, in association with ACCEI Bengaluru Center, successfully conducted a 10-week-long lecture series on sustainable engineering. The series that benefited the student community and the professional engineering community across the nation was very well appreciated by all. ACCEI Institute Working Group has now stitched together another series of technical lectures on structural engineering, which is commencing today. As you're all aware of, this is an 11 lecture series. The series is aimed towards benefiting the student as well as practicing structural engineering. Friends, here is a brief on today's presentation. It is Introduction, Structural Engineering as a Responsible Career. Structural engineer should take up the career with knowledge, passion, and responsibility. Unlike other domains, structural engineering profession deals with economy of the country and safety of people utilizing the constructed facilities. Hence, designing a structure which is safe and serviceable is a primary responsibility of the structural engineer. The lecture today deals with structural engineering introduction, challenges, some of the projects dealt by the speaker of the day, career options, and professional issues. Structural engineer's role starts with design intent and involves in preparing design basis, code provisions, load calculations, coordination, structural systems, material selection, construction engineering, periodic checks during construction for compliances, as-built working drawings, periodic qualification of the structural safety and retrofitting if required. Also, coordination with other investigations such as geology, topography, geotechnical, groundwater, environment, etc. They're also going to be covered by the speaker today. In spite of so much responsibility of the structural engineers, their role is limited to issuing reinforcement drawings and assuming SBCF. Also, the government of India did not come up with legislation to recognize and make professional engineers. Due to lack of the act, structural engineering is losing its sheen and built environment is in severe stress. The importance of continuing professional development is elaborated here in today's talk. Also, need for training engineers, motivating them to be responsible is explained. Knowledge and experience in understanding the structural behavior, structural systems, detailing, construction engineering, quality practice is stressed for structural engineer to deliver the responsibility more effectively. Friends, I now request ACCI Vice President North, Mr. Satish Raipure, to kindly introduce today's speaker, Mr. P. Surya Prakash.
He is Vice President West.
Oh, I'm
Satish
sorry.
Raipure,
Vice President West, Satish Raipure. Mr. Raipure.
Thank you, Mr. Ranganathan. Good evening to all. I thank Ajit Sabnis sir for giving me this opportunity to introduce a very eminent engineer, a consultant, and a very good human being. He is a graduate in civil engineering, passed out in 1986 from JNTUK, and then he did his MS in structures in 1990 from IIT Madras. After 5 years, he started his own company, a Sustainability Consultants Projects and Consultants Private Limited. He is also founder and mentor of Smart Infra EST, a trust dedicated to civil engineering, employability, and employment. He is a member of many organizations, and he was the president of a Association of Consulting Civil Engineers India in 2013 to 50. He is also a founding president of PSI since 2013. He is also expert committee. He is also member of expert committee appointed by Government of Andhra Pradesh from June to October 2019 to review the projects of irrigation, urban development, and roads and bridges. He has also written a book, Design and Instrumentation of Construction Towers. Also a guest faculty dedicated to construction towers in CTR, ESCR, Hyderabad. He is chief resource person for LEAP lecture in 56 topics of smart infra. He has also developed a software who won the ACCE CTC Best Software Awards in 2007. He has chaired number of conferences, organizes number of conferences nationally and internationally. Hardly there is left that he has not designed. He has designed almost all the types of structures, housing projects, whether it may be housing projects, building, residential, commercial, IT offices, industries, metros, roads, bridges, hangars, and many more. His consulting firm has many prestigious clients, including Ministry of Defense, ILFS, Tech Mahindra, GVK, PMR, BSNL, Idea, Airtel, Tata, Janapriya, Ashoka, etc., etc. today we are very fortunate to have Mr. Surya Prakash to speak on this subject of his liking, and we have present to you the immediate address of Surya Prakash. Thank you.
Yeah. Thank you. Thank you very much, Mr. Raipure. Now, I request speaker of the day, Mr. Surya Prakash, to kindly make his presentation. Surya Prakash.
Good evening to all. Thank you, B. Rangnathji, moderator of today's session, and of the working group ACCE Institute of Ajit Service, President ACCI and Vice Presidents of ACCI, and all past presidents and present Vice President, past Vice President. It's my privilege to take this session today. Most important topic and close to my heart. If I'm given the presentation permission, I'll start my. Yeah, thank you. And also, what is the time I can take, sir, for this?
Sir, actually, you can take full time, but last 10 minutes, I think, for the
Okay.
interaction.
So we have 5 minutes. I'll
Yes. Yeah.
presenting. Okay. Request all the
And
participants.
I request everyone to mute themselves. I
Anand
request
Dave.
everyone to mute themselves and put off your video so that there's no echoes heard. Thank you.
So is it clear, sir? Screen? Can you see my presentation?
Yeah,
it is
we can
clear.
see your screen. Only thing is enlarge it.
Yes, sir. Start the PPT, sir.
Okay.
Start the PPT, sir.
Okay. I have started. I'll see
Go ahead, sir.
if I.
Full screen, sir. Full screen. Next, full screen. Okay.
You're not getting the full screen, sir?
No, sir.
Go to slideshow.
Go to,
Yeah, it is in slideshow only.
no, start the slideshow, sir.
Oh, yeah, it is on slideshow only.
It's not coming in full screen.
Surya Prakash, I think you are on your presentation mode. You are on your presenter's mode. Exit from presenter's mode.
Oh, okay. Okay. So, are you getting the full screen?
No, I think, yeah, screen is changing, but I think you will have to
This
get
is
out
what
of this.
I don't know. In my laptop, it is showing
Full screen. Oh,
the settings. Okay. Oh, swap present preview and slideshow. Duplicate slideshow.
You can close and restart if it is okay.
Now, sir.
no, sir.
Now you are getting full screen.
No, sir.
Yeah, now we are getting.
Yeah. We
Now
got it, sir.
Hello.
Yes,
We
sir.
are getting now, Surya Prakash.
Are you getting the full screen now, sir?
We are getting
sir.
a full screen. Yeah.
Okay. Thank you. So every time this technology makes us pass through this, however much preparation we do, and thank you all for your patience. I will start off my talk without using much of time. So today's most important topic, structural engineering as a responsible career. I'm sure most of us are all structural engineering consultants. And I'm sure we are also having many students who are aspiring to be structural engineers in their career. And I have purposefully put this picture with the tension. I mean, structural engineering for many people is a tension, but definitely for those who work with passion, it is a career. And I want to remind you all about a saying: if you like your job, you are not working. Same is applicable to our career, structural engineering career also. In fact, I claim to be one of such people who enjoy this career of structural engineering. And so, with this brief introduction, I will start off today. And the overview of my talk today is introduction to the topic, and we'll briefly touch upon structures, and we also give introduction to structural engineering and responsibility as a structural engineer, and it's a responsible career, how responsible we are. I request all the participants to mute, please. I request all the participants to mute, please. Yeah. And professional issues that are being faced by our fraternity and the challenges before us. So this is my topic overview. Please don't give any annotation requests. I will not approve any annotations. Please don't disturb us. The flow will be disturbed. It's a very nice topic for all of us, and let us be focused on what I talk, and you all get time to ask me any questions towards the end of this session. Or you can also type your questions in the chat box. So, civil engineering, as was introduced in the beginning also. Request you please mute your mics. There's a lot of difference to everyone.
Sorry, Prakash.
Yeah.
I'll mute all once. If you get muted, please unmute yourself.
Yeah. Okay.
Yeah. Go ahead.
Am I audible? Yeah. Okay.
Yes.
Thank you. So, engineering, as we all know, is the oldest branch of engineering, and of this structural engineering is a very vital subject, like cardiology in medicine. Structural engineering is in civil engineering, because we deal with the life of structures, life of people, and also the performance of the structures for serviceability. And without construction, there is no structure. So construction also is very important, and we cannot be structural engineers without having the knowledge of construction. And we all deal with constructed facilities, basically. Any constructed facility, as long as there is a civilization, we need civil engineering, we need these constructed facilities. And for these constructed facilities to be stable, it is the job of structural engineer to ensure the stability of the structures and the serviceability of these structures. It is the role of structural engineer. And so today we are going to talk about this responsibility, the responsibility of the structural engineer to make the structure serviceable during the life of its performance, service life, and also the stability of the structure even in disasters. In disasters, we must ensure the stability because it deals with the life of people who are living in it. We have seen so many disasters, whether it is tsunami, whether it is cyclone, whether it is earthquake, whether it is fire, all disasters. It is the responsibility of the structural engineer to draft the design basis such that we'll be able to deliver serviceable and stable structure. So with this brief introduction, let us look at what all the structures we deal with. So housing, primary, very primary thing. If you go back to the ancient days, it was the quest of a human being to identify a living place. Then for food. Now we deal with housing. Transportation is become the biggest challenge for engineers now. Urban transportation, all elevated bridges, expressways, or metro rail. Transportation is gaining a lot of importance after interconnecting the cities. Now it is within the urban scenario. Next, buildings, the offices, commercial establishments, entertainment and leisure, hospitality. Now we are talking about hospitals to be built. So it is the responsibility that we have to build these buildings in a given time with the safety and serviceability. And exhibitions and industries, the production, industrial production, power, communication, irrigation, these are all domains where we have structures. There is no domain without a structure. If you have a constructed facility, we have a structure connected with it. So sports stadiums, tourism and entertainment, temples. We have so many temples in our country, which are also the structures that are durable and that facilitate the people to offer their prayers, and bridges connecting the cities, space structures. Now we are talking about going to Mars and all. So the space structures are also happening, and airports, ports, and railway stations. The picture you are seeing on the right is a railway station in China. You can see how complex the large span structure that we have to deal with, and skyscrapers now, whether it is Hong Kong or Dubai, all these small cities where the density of population is so high, we are forced to go for skyscrapers. And now India is catching up with that. We are seeing 250-meter tall buildings in Calcutta, Gurgaon, even in Mumbai has the tallest building. So we have to deal with these skyscrapers, transmission towers. That is for the power transmission. Also, we deal with structures, and I particularly talk about it because transmission tower is the real challenge for a structural engineer, because it is the only structure that is prototype tested even before implementing the design. So every designer has the responsibility to pass these structural design and detailing through the prototype testing. Next is the radio high mass. This is another area where we have a very important communication going through this radio high mass, and we deal with these things. So now, Shashikant, can you please mute? Please mute your mics. It is getting the, yeah, thank you. It is still on. Yeah, that's fine. Thank you. Next, now let us talk about the structure. What is a structure? It covers. Basically, it's a very, and it connects like bridges. It supports the high floodlight masts. In cricket stadium, you see the mast, it supports the lights. It protects like baffle walls. It holds like silos. It holds the grains. It transfers the loading and isolates the structure. So even a structure isolates and it elevates water tanks. So like that, we have so many types of structures which we deal with. And for all these structures, the primary thing a structural engineer deals with is the loading. So we have to have the clear understanding of what are the loads that are going to be transferred, that are going to be isolated, that are going to be connected. That is the job of a structural engineer. So we must have the ability to transfer these loads effectively to ground finally, the support. And the materials, next important thing is the materials. We have concrete, steel primarily, but all the materials we have, nowadays composites we are talking about. So we should have the complete understanding of these materials when we talk about the structures. And we also design the structures deal with blast resistant machine formed structures. That means nuclear attack, we design the structures. And flood, to handle the flood situation, to handle the cyclone, to handle the earthquake, we deal with the structures. So the structures have to be resistant to any of these loads, and we design these structures. And elements, structural elements, next. In a structure, we have the elements. In a structure, we have the structural system. So as a structural engineer, we deal with these structural elements and the structural systems. Next, we deal with the forces that are acting upon the structure, whether it is the earth pressure, whether it is the hydrostatic pressure, and we have to understand the deformations, whether it is the displacement or rotation, all these deformations we deal with, and the stress and strain. This is the basic elastic theory. Also, we should have the complete understanding of the elastic theory, stress and strain, and mechanics. And we also deal with the structures which are linear, like beam, simple beam, or a bridge girder. And we have planar structures like a slab, plate, shell, and we have the spatial structures. So these are all the, by geometry, we deal with the structures. And in a structure, we have to have the understanding of the material properties, which are the main material properties we deal with. That is the Poisson, the thermal coefficient, coefficient of thermal expansion, elasticity, rigidity, rupture, specific gravity, toughness of the material surface and hardness of the surface, and plasticity and ductility. These are all the properties of the materials we should understand. We should have the clear understanding. Next is the section properties. Whatever elements that we use in the structure, the basic area of cross section, moment of inertia, section modulus, and radius of gyration. So these are all the section properties for every element that we use in the structure. And next is the phenomenon, behavior of the structure. That is buckling primarily in compression. When we talk about, we should understand the buckling behavior of the structures. Again, this comes from the theory of elasticity. And the creep, sag for tension cables, like, and shrinkage for the concrete. And creep is associated with sag and these cables actually. So we should have the, and also of course concrete when we deal with coefficient and creep correction in the during construction. Next is the dynamic behavior. The structure dynamic behavior, we should have the understanding of the natural frequency of the structure and time period and the resilience of the structure. That is elasticity basically to do it with. But when we talk about the structure robustness, when we say robustness, it is the resilience associated with it. And the stiffness of the structure, a structural engineer should have the complete understanding of the stiffness of the elements and relative stiffness between these elements. That is the most important thing. And next is the behavior of the structure. If you all, any one of you have read the book by Purushothaman, Reinforced Concrete by Purushothaman, he says that when you, any structural engineer who understands the failure mechanism, that is the behavior, you will be able to detail correctly, because the detailing comes to the fore when it comes to the failure, basically. It can prevent the failure or it can prevent the collapse. So we should have the complete understanding of the behavior, the intuitive understanding of the structure. And the symmetry helps again in the stability of the structure. Let us all imagine as structural engineers, nature has the symmetry. So let us build the symmetry into the structure in a structural system. And then it becomes easier in performance. It becomes easier to predict the behavior, the forces or stresses and boundary conditions. Finally, very important thing, we should all have the understanding of the hinged condition, fixed condition, roller and clamped. If you see Timoshenko, book by Timoshenko, all these terminology are used. So we should have the understanding of these boundary conditions. Now, just for the sake of introduction, some of the structures we are looking at, elevated metro in Delhi, and it's a bus station in Vadodara, and this is a mass housing happening everywhere. Particularly, this is a photograph of Hyderabad. We are seeing the underground metro and the tunnels, and we are seeing the irrigation structures, and this is the power plant structures, and then beautiful Bandra-Worli ceiling bridge, and we also deal with these wind turbines, wind towers, and the airports now maximum happening. We are dealing with highways, we are dealing with tall buildings and cooling towers, very interesting structure in power plants. So these are all some examples, structures. And next, let us look at what is structural engineering. We just understood what is the structure, and now it's an introduction to the structural engineering. We deal with the design intent. There is an intent, a design intent defined by the end user or the client, and the functional requirements are defined in this design intent. For example, the life of the structure. Sometimes we may deal with a structure which has to be durable for a service life of 150 years. So this is defined in the design intent. and it should have the washability, it should have the food and drug regulations. All this will be defined. And next is the design basis. The structural engineer, after understanding the design intent, we draft the design basis, that is the materials. Please mute your mic, please. You are disturbing everyone. Sir, should we mute all again?
Yeah, I'll do that. Yeah.
Yeah, thank you. So after understanding the design intent, we draft the design basis. In the design basis, we define what is the structural system, what are the materials we are using, what are the standards we are going to follow, what are the design manuals we are going to follow, and what is the construction method we are going to implement, and the practice of design, construction, and quality. So these are all defined in the design basis, which forms the basic document for design. And next is the understanding. In structural engineering, we have to understand the forces that we deal with: the compression, the tension, the shear, the axial force, the bending, and torsion. So these are all the basic forces that we deal with. And next is the vibration, damping, mode shapes, and deformation control. So these are all the things. And next we deal with the testing and simulation. As I said, this is a model, scaled model. We have wind tunnel studies, we have the shake table test, and we also simulate, for example, if we are dealing with hydraulic structures, we have to simulate the hydraulic flow and also test the behavior of the structure under such hydraulic forces, hydrostatic forces. Next is the preparation of models and investigation is also part of structural engineering. We have to understand the geotechnical, geology, and all. So we have to have the understanding of what all investigations we have to do before even planning the structure and structural system. Large spans. As I mentioned, please don't ask me for annotation. I cannot give permission. And large spans, tall structures, robustness of the structure, limit states. Now we are talking about limit state of serviceability, limit state of collapse. We should understand the basis of our design. Normally, we go for extreme loading. That means beyond the design load, we check for the limit state of collapse and also robustness. And for normal function within the design loads, we'll go for limit state of serviceability. And next, we should also have the understanding of repair, rehabilitation, restoration, retrofitting. And we also should have the methods of pre-stressing, post-tensioning, because that is almost becoming the order of the day in almost all the structures, because the spans are increasing, the heights are increasing. So we have to use these technologies also, and the structural engineering should deal with these things. And next is the understanding of the construction methods, fabrication methodology, and erection methodology. And we should have the understanding of the erection, particularly the capacities of the handling cranes and all that, and method of erection, and loads. Again, in structure also we should have the idea of the loads, and in engineering also we should deal with the loads. Next, acceptance criteria. This is the most important thing many people miss, as I see. In IS 456 itself, we have the definition of acceptance criteria, how to accept a particular concrete. We have acceptance criteria. And can you reject the concrete? Same for every material, whether it is steel or deflection, all this, we must have the complete acceptance criteria. Next is the top. I mean, what is the verticality of the column? What is the plane levels of the slab? All tolerances and foundation excavation tolerances. The structural engineer should have the idea, and the construction methods and the exposure conditions. We are seeing the picture here. The exposure condition is not taken care properly. So is the corrosion and to fail. And fire rating is another important thing because it deals with the safety of the corrosion protection water and weatherproofing. Also important because the exposure condition that we define in our design basis should be maintained by providing proper weatherproofing and waterproofing. And the periodic qualification of the structures also is very important. We issue the stability certificate. It's not that if a structure is designed for 50 years, once you issue one certificate that is valid for 50 years. So all structural engineers should know that any stability certificate that we issue should be valid for maximum 5 years. Because every 5 years, there can be caudal provisions change. There can be changes in the atmospheric conditions. There could be changes in the site surroundings and all. So every structure needs to be qualified once in 5 years. So we must qualify in our stability certificate about this point. So this is a typical wind tunnel study because it's interesting. I'm showing the picture of Burj Khalifa when it was tested. This is the photograph in a wind tunnel experiment. And this is another wind tunnel study for a tower. You can see the surrounding structures that is category, terrain category is reflected in the wind tunnel to get the realistic force coefficient for estimation on the structure. So this you can see how the wind, when we do the wind tunnel study, we can exactly predict the wind force because for tall structures particularly, it's very important to understand the behavior and wind drag coefficient and force coefficient. So it is very important to conduct the wind tunnel studies. So here, when it comes to two buildings, you can see the change in the wind flow. And next, when you have the multiple structures, how the wind flow. So for a structural engineer to do the real structural engineering, it's very essential to understand the loading pattern. So Bill Baker said once in Bengaluru when he was here, when press people asked him how he designs the structure, he said he will confuse the wind. That is the way he put forward. So we must, whether it is laminar flow and turbulent flow, which we use in the technical terms, the turbulent flow is confusing the wind actually. So the turbulent flow will give the lesser wind force on the structure. So as a structural engineer, we should understand this, how to reduce the effect of loading on the structure. So next most important topic of the day today is the responsibility. It is the responsibility of the structural engineer. So let us look at what are all the responsibilities we deal with to suggest most efficient, optimum, and cost-effective structure. It is the responsibility of the structural engineer. Understand the behavior, stress levels, and failure. I come across most of the structural engineers today, they say they will go to the stat and get the output, and they say, I have designed, I have given the, then you are not a structural engineer. We must understand what is the maximum stress level that is permitted and in which structural element you are allowing stress utilization factor to be 0.9 or 0.95. So we must, as a structural engineer, we should understand, then if it is a critical element, we have to analyze the structure by failing that critical element which is subjected to the maximum stress level and understand the robustness of that structure. So it's very important. And also we must have failure mechanism. As I've been telling, any good structural engineer in the structure. So that is the job of a structural engineer. That is the last resort, life-saving step actually to understand the failure and protect the structure. Loads, next 2D design. Loads as a responsibility of the engineer to estimate the loading accurately as per the code, as per the conditions of the structure, whether it is earth pressure, whether it is hydrostatic pressure, whether it is pore water pressure. All this we must understand apart from live load, dead load, wind loads, and moving loads, vehicle loads, and fire tender loads if you are designing for the fire tender movement. And next is the pencil calculation. Please, most of the structural engineers I'm seeing nowadays don't do this pencil calculation. Before getting on to the real analysis and modeling, we must understand what will be the probable estimated load on the maximum column load and the maximum bending moment in the and you can use the methods of cantilever method, Wortel method, and other distribution stiffness, what is that equivalent frame method? So factor method we can use to estimate the moments and use the pencil calculation for estimating the loads and estimating the forces. Then decide the method of analysis depending on the loads you are getting and the extreme conditions that you may come across. Based on that, you decide the method of analysis. Next, we must also know the codal provisions, latest codal provisions like 16700, National Building Code, and 1893, our 13920. All these codes, we must have the 875, 3370, all these codes, 1373. We have to have the complete idea of these codes, manuals, and the practice of design, construction methods, fire safety, and weather conditions. So, and analyze the structure and design the elements and check again the analysis results with your pencil calculation, and then detail the structure and again check the detailing and test if required your design, if you are using the design for repetitive use. As per code again, if you are repeating the design for 100 elements, better test one element. Whether it is in precast or any steel structure, it is better to test one element and visit during construction stages. It's very important. There is no structural engineering or no structural engineer can take the responsibility without visiting the site during construction and checking the compliance and quality, and approve shop drawings, bar bending schedules, method statements, and technical specifications of the construction. Then conduct acceptance tests, issue stability fit to occupy certificate. Normally, structural engineer signs the stability certificate at the time of getting the permission, but we must also insist on issuing fit to occupy certificate after completion of the construction. Next, prepare the as-built drawings and hand over to the end users, and periodic inspection of quality control registers. This is another most important thing, responsibility of the structural engineer. Defect liability period, periodic renewal of stability certificate, repair, renovation, and retrofitting or rehabilitation. These are all important aspects and responsibility of the structural engineer to understand and implement whenever it is required. So, responsible career. Now, in structural engineering, we are taking as a career. So, we must have the safe, serviceable, sustained structure, protect from natural man-made disasters, knowledge of material, methods, behavior, loads and systems, technologies, construction technologies. For rigid monolithic construction, there is a precast construction, there is modular construction. All these technologies, we must have the understanding before. And the people nowadays, we are seeing transfer slabs and all that, which of course I don't support. But these are all the systems we should understand. And the standards, codes, proof checking, peer review, and the testing, and the no failure mechanism, detailed to prevent failure, and design for serviceability, estimate the actual stresses to be within allowable or limit state actually. So this is a very, very important thing. Some of you may feel I'm repeating this terminology as we move forward, but all important points I'm repeating so that end of the session we remember what are all important definitely. So it's very important, please note. And soil structure interaction and foundation design, never go with the safe bearing capacity given by the client or geotechnical engineer. As a structural engineer, we must understand what is the soil strata below. And also nowadays it is very important to understand the stream, water stream underground. We must understand because it will affect the hydrostatic pressure. Slope stabilities during excavation and water retaining structures for the provisions of water retaining structures and highly corrosive environments. And finally, it is collective responsibility. Never think structural engineer alone is responsible. You must make everybody, whoever is planning, whoever is designing, geotechnical, proof checking, and supervision. So we must not issue stability certificate in isolation. Please insist all these people involved should give a collective stability certificate. And quality you should have plan, quality assurance, quality control, quality audit, and quality vigilance. Only when all these happen, the structure will be safe and we can take the responsibility of a structure. Next is the documentation. This is where I come across many engineers failing or being made responsible in the absence of documentation. Whatever construction happens on the site, we structural engineers should insist on documentation at the site so that when we visit the site, for example, concrete trip sheet, where mix particularly or from batching plant, we must have the data of the dispatch time and starting of the utilization of concrete and the ending of the utilization of concrete. This time record, time sheet is very important. And a professional engineer. So we are all professional engineers. Unfortunately, in our country, still there is no proper recognition of professional engineer. Though Institution of Engineers accord this status of professional engineer, and also the Engineering Council of India has also started professional engineer according, but it is not fully supported by any legal statute actually. We have the memberships like ISTRUCTI, we have Association of Consulting Civil Engineers, we have Institution of Engineers, we have Indian Institute of Bridge Engineers. All these associations we have, you can take the membership. Ultimately, we have to be responsible, even in the absence of such a statute or bill act. We must behave as professional engineers. We must develop our own systems to ensure that every structural engineer works with responsibility. And for that, the most important step is the continuing professional development, for which ACCE has already initiated this ACCE Institute for this continuing professional development. In fact, I am one of the most benefited engineer, I can say, out of our association. For the last 30 years, I am actively involved in our association and I update my knowledge by attending all the conferences. So every year, a norm, international norm says you have to spend 50 hours of continuing professional development. And please try to do that. And vendor updates, this is another important thing. Every structural engineer should have the knowledge of the products and technologies that are coming up. And next responsibility is detailed investigation, understanding the geology, understanding never say site, please. Use the word topography. It's not the just level and boundary of the site. We must have the topographic understanding when we are designing. Somebody RA is speaking. Please mute your mic, please. Uddar, yeah. Please mute your mic. Ambrish, please mute your mic. We have to mute, I think, across.
Okay, I'll do that.
Yeah, thank you. Next is the understanding of the seismic loads, cyclone behavior, that is the narrow front wind, for example. We have now fire, blast, and the floods, and the construction practices. So next, this is the things how we use damping and can be used in the design. Next is taken when we talk about durability of the structure. Actually, the most durable structures will look so beautiful. Actually, so we must have the idea of bringing in the element of durability and the service life of the structures. Next, as I explained, design intent, design basis, inception report, and coordination. The coordination is between a structural engineer's role is to coordinate with the civil aspects, architectural elements, and mechanical, electrical, plumbing, automation, communication. Nowadays, we have so 6 disciplines in the design. So it is the first job is structural engineer. The thing that is going to commence in the construction. So unless we do the coordination with all the services, like signage is also we have to coordinate. The signage and internal transportation, the service lifts and all that, we must have the understanding of the coordination and budget, time, a structural system. What is the budget available? What is the time available? And what is the construction technology that we can use for the given location? Next is the design. Have the ambiguity about this service life design of the structures. I want to be clear, 456 still doesn't give any definite design life for a structure, and it's only prescriptive, and it is 50 years life for a reinforced concrete structure. And if we want to go for service life design, even internationally, it is very restricted. So we should have that understanding and design. American Society of Civil Engineers and American Concrete Institute have with certain formulas for estimating the service life design of the structures. And next is the geotechnical investigation. It is the responsibility of the structure engineer to draft the extent and the depth of investigation that is required and the number of tests that are to be done. And topographic survey. So this is a typical drawing of a topographic survey showing all the features around the site. So we must have the complete understanding. Your boundary alone, we must go beyond the boundary, understand the surrounding structures. So this is the I'm showing when we go for rivet modeling. So you have the electrical, plumbing, air conditioning, firefighting, and then coordinated drawing of the structure. So we must building with 750 depth beam for a 225 meter. So it is the responsibility of structural engineer to understand the spot feature investors. We should not design structural design until we do the service. And design and sometimes we deal with temperatures in India minus 30 degrees to plus 50 degrees. So that is the 80 degrees is the temperature we're dealing with, and we have to keep the temperature also in mind while designing the structure and exposure condition. And mess with this. Coordinate and modeling boundary condition. West contours and benefit diagram, shear force diagrams, and understand the structural behavior before we go.
Surya Prakash, I think.
Though we are going to utilize the software like ETABS or STAD, we must have the understanding. Pardon? Hello?
You are getting cut in the middle, Surya Prakash. Can you hear me?
Something?
You are getting cut in the yeah, you are getting cut in the
middle. Maybe because
cut in your.
Oh.
Yeah. I request everyone to please. No, I request everyone to please close their video. Please close their video. Also mute.
Pardon?
Yeah. No, I'm requesting everyone to close their video.
Yeah, that's better. Actually.
Video.
Yeah, mute also, please. That mute your.
I'll mute once again. I'll mute once again. Okay, go ahead. I'll mute once again.
Okay, that's fine. Thank you.
Okay, go ahead.
Yeah. Please close your videos also so that the network will bandwidth will be better utilized if you don't use the video. Okay. Program we are talking about whether seismic accelerogram or accelerogram. We must estimate the shear force, story shear. We must estimate, design with the cantilever method, and understand the behavior. So, design for stresses and check for serviceability criteria. That is particularly the deflection. Many people I see, you just take the deflection that you are getting from the SCAD or ETABS, and we'll go ahead with that. But please remember, the deflection we get in the SCAD or ETABS is only elastic linear deflection. So as per the code, we have to estimate the long-term deflection and check the serviceability. Most of the buildings nowadays we see have the cracks and damp, non-checking of these long-term deflection, particularly the cantilevers and large spans. Beyond 4 meters, beyond 5 meters, we must have the check for serviceability with long-term deflection, whether it is a slab or a beam. And then detailing and check for bar bending schedules. So structural engineer must check the bar bending schedule before commencement of the construction. Construction engineering, method of erection, and consider the construction loads, and these counter props is a very, very important thing. Structural engineer should approve the construction methodology with the and formwork. Define construction methods, periodic visits during construction, as-built drawing, periodicity of 5 years, inspection and certification of the structure. So this is the construction engineering we are talking about, how the shuttering has to be placed and what are the steps you are taking on the existing structure is very important. Crane loads particularly these days. So structural engineering is a very challenging career. It gives a lot of satisfaction when we are successful, and it gives a lot of eternal happiness. Also, I always say when we design, I always equate structural engineers almost near to God, because God gives life to human beings and life to so many living beings, and we give life to structures. We give stability to the structures. So that's a satisfaction we get by being perfect in the design. So we are creating the structures and we are creating the civilizations and we are giving life to the structure, and healthy structure saves healthy lives. This is the statement. So being a structural engineer, we are responsible. At the same time, with the responsibility, we have satisfaction and happiness. So this is a structure which we have designed, a 30-storied structure with a buttressed core actually. This is gives very economical design which we have done. And these are all the this is the structure which is constructed 30-storied buttressed core actually. And next, this is a mass housing in which we have done 3 technologies, precast and my1 and conventional in the same project. And we delivered in 12 months the given target. And this is another commercial building which we have done with a flat slab and with the post-tension slabs in 2004, 2000. And this is IT towers in Bengaluru, which we have done in 30 months. That is start to occupying the building. And this is another IT tower in Bengaluru. Again, a total of 1.8 million square feet with 14 floors. And this is a Metro Rail Gurgaon project, which we have done again using precast, and the stations are designed with precast eye girders, which is very, and this is another hangar at 13,000 feet above mean sea level, minus 30 degrees temperature. And this is a structure with 30 meters automatic door closing because of these temperature conditions. And this is a 360-meter long pre-engineered building, first pre-engineered building of Kirby plant itself. The alignment of the gantry and the accuracy of the tolerances is very important in such building, which we have done. And this is a pyramid of 50-meter plus span, height and span. So this is also done near Hyderabad, Katkal. And this is another steel structure, interesting architectural steel. Structural steel itself is used as architectural element. You can see we have designed, this is a completed photograph. And another feature here is the stitched boulders. We have not gone for the conventional foundation. You can see this structure is resting on the boulders itself. So we have designed such a structure. And this is a pavilion, sports pavilion with a 11.5 meter span and with the cable supported. And this is a 100-meter FM tower at Barmer, Rajasthan. And these water tanks, elevated storage reservoirs, we have done funnel type. And this is in Salem, Tamil Nadu. We have done common effluent treatment plants for 7 districts. And these are all the water retaining structures like irrigation structures, aqueducts we have done. And this is industrial structures, water tanks. And this is the sterilite, the steel structure of 47-meter span. You can see it, we have used a box steel girder with a latticed purlin in this. So many interesting structures. And this is a snow world in Hyderabad where we have used all post-tension slab, steel structure, steel we have done, and we have done a slab without reinforcement with only polypropylene fiber. So these are all in, and this is a transmission tower of 50-meter high being tested prototype. So this is another very challenging thing. And commercial building in Hyderabad and food processing unit in Jahirabad. And these are the poles, concrete, spun concrete poles, which were done about 20 years back with MAT grade concrete and a 40-meter pole being erected in 2 days. These are all the interesting structures. So as response area, we must understand the obligatory spans for function and efficiency, optimal and technical investigation, topographic survey, and concrete mix design by responsible agency. This is most important. Many people miss it actually. Always insist on mix design because we have to use the concrete by design mix only, no nominal mix. And supervision by qualified and experienced engineer in charge with similar projects involvement. Slab levels record. This is very, very important. 7 stages will maintain the record of levels for post-tension slabs, particularly before casting and after casting, and before stripping, after stripping, before stressing, and after stressing. The stages where we maintain the levels record of slabs and surrounding structures, monitoring and surveillance for vibrations. This is also important. We have, when we are doing large-scale construction, we must also install the monitoring for the structures around, because if you are affecting any structure surrounding your construction, we must have the complete data. Calibration of batching plants and third-party checks, verticality, orientation, eccentricity, dimension, thickness, planes and level, foundation, soil bearing test, pile load test, plate load test, and structure loading test. Also, whenever you have issue with the structural design, you must do the load test, vibration test, and a 100 scale drawing of framing and tower. So this I always follow. I advise the structural engineer, you draw with your hand the structure, 100 scale, 1:100 scale. It will give you very good understanding of the structure, how it looks, whether it is healthy or efficient or not. Water barrier, weatherproofing, exposure conditions, and ductility and liquefaction. Understanding of the liquefaction. Whenever you deal with the soils of silty and sandy silty clays, you must provide the soil improvement, ground improvement for liquefaction. And visualize the structure, calculation, structure idealization, preliminary member sizing, materials, geometry, loads, boundaries, boundary condition, model, analysis and results, check the design, and ensure the issued with construction methods and the structure coordination with services, facade and finishes. So this is typical certificate to be issued as per National Building Code. And so here we assure that the structure being designed by us will be stable and serviceable according to the codes against natural disasters as applicable. So we must qualify this certificate saying that with the periodic inspections. Next is the ethics in profession. To maintain uniform standards, every structural engineer, some builders come and say, sir, so-and-so is giving less steel. How anybody can give less steel? It has to be with the same code, the same standard. It will give the same result. We are not artists to give any better. So every structural engineer should follow the same standard and respect the fellow professionals and avoid unhealthy competition and maintain the dignity of profession with other profession and use the materials optimally and as demanded by the structure and to maintain professionalism with vendors. This is very, very important. We should never give any undue advantage to any vendor in giving the specifications. And the challenges in profession, we have public trust issues. People think that the engineers are not honest. We have to build that confidence and trust. Employability of engineers is a challenge we have. Ethics in profession, standard operating process, and registration of engineers in every ULB is also a challenge we have. And recognition of engineers is there. So we must have approved apex body, Indian Professional Engineers Council, which is in draft stage. We must all work to get this IPC enacted and regulate the industry needs professional engineers and regulate the division of skills in balanced approach like geotechnical engineering. Consistent for every engineer and conserve material resources and energy by using effective human resource, that is engineers actually. We can conserve the material resources and energy and spend on disaster prevention and reduction rather than disaster management. So good engineering can prevent disasters. For Indian needs, affordable housing, healthcare, urban infrastructure, traffic management, flood management, and manufacturing. And so finally, the prevention is better than cure. So engineers, motivate engineers to be engineers, enlighten developers and builders to engage engineers. Nurtured engineering gets better engineers because we are all professionals. As we work more, we become more professional. Buildings get distressed without building engineers. So no causes or remedies for projects with good engineers. So this is a very, very important thing. So finally, the professional challenge is unity for all engineers and integrity among engineers and leadership among engineers, managerial abilities of the engineers, public trust on engineers and professional ethics among engineers. And while other systems and procedures, healthy competition, deliverability of the projects, we must ensure the deliverability, quality and economy. So these are all the challenges we must deal with in our profession. And so thank you very much. Now we have time for questions. I request the coordinator to take over and take the questions. And if any one of you have any questions, you can email me also if you have missed now, or you can WhatsApp on this number, what I have given. So thank you very much for your patient hearing. And I thank organizers for giving me this great opportunity of talking about structural engineering as a responsible career. I have taken it as a responsible career. I am working for last 31 years. And yeah, 100 scale drawing, somebody asked me now. Scale is 1 centimeter is 100 centimeter, or 1 meter is 1 centimeter. Right? So draw using the scale a beam of 10 meter span with 10 centimeters and a column of 3 meters height with 3 centimeters. So you draw the whole frame, cross section, you will be able to follow the structural behavior very well when you draw it. I designed many towers, 90 meters tower drawing with my hand with a scale on my table. So that as a structural engineer, you should get the feel of the structure. That's what I said. So 100 scale is urban local bodies. ULB means urban local bodies. A structural engineer has to, in every local body, suppose I am from Telangana, there are 30 cities. So as per the present problem, if I registered as a structural engineer in Hyderabad, I have to also register as a structural engineer in Karim. What I'm saying is we must have every engineers in every state at least should work to get the structural engineer registration. Once done, should be applicable for a state. they have done, in Kerala they have done. So every state you can do. AP also they have tried. I think they have successful. So like that, every state you should work for getting the structural registration. So I have answered. I request the coordinator to now take the questions, and I'm stopping the sharing. Now we can have the questions and answer session.
Okay. Thank you. Thank you very much, Mr. Surya Prakash. You have put all your experience into very simple form and thrown open a lot of thinkers in this group. And I really appreciate the way you have presented it. Thank you again from the Association of Consulting Civil Engineers India. Now the floor is thrown open for questions to be asked. Anybody wanting to ask a question, they can put up their hands.
I just see one question. Your suggestions for fresher engineers, structural engineers. I'll answer that. A structural engineer preferably should be a postgraduate, according to me now. And you must have done academically good and have the complete understanding. So please become a first good structural engineer academically, and then work as an intern while doing your project itself in a company, and work as a structural engineer. Then you will get the understanding of the structure. Then once you complete your post-graduation, you will be ready to work in the company. We are recruiting like that. We have trained many people as interns for their one-year project in our office and recruited them after completion of their project. Many times, not only now, even for last 30 years, I am doing that practice. Postgraduates can do the internship in companies.
Thank you.
Can I ask a question, please?
Who is it? Madhav?
Madhav Kamath, go. My video is off.
Please go ahead, Mr. Madhav. Please go.
See, one of the problems I have seen, I have about 40 years of experience in the field. One of the problems is very poor detailing in many design offices.
Yeah.
Detailing is not up to the mark, and part of the problem I think is because designers lack site experience.
Yeah.
What do you think, sir?
Yeah, actually, there is a good practice in some of the companies who will insist on 2-year on-site experience for a structural engineer. So everybody follows that thing. And as I said in my presentation also, every structural engineer must visit the site during construction. You cannot give the drawing and forget the project. So till completion, one engineer must visit the site and monitor the construction and also the quality. And of course, the compliance of the drawings. That will give good experience for them.
See, site experience for a designer would give him a proper grounding in designing a structure for constructability.
Yeah, correct. That's right, sir. I agree with you.
Thank you. Next, you can unmute yourself and ask a question. Mr. Madhav, please mute yourself.
I request somebody to see the chat box and give me questions, please.
Hello.
Someone is asking questions, they can go ahead. Mr. Huda.
Sir, I myself am a postgraduate structural engineer, worked for ISRO for 34 years. I joined department in 1986. Great personality. R.D. John was the chief engineer. I was posted to quality control. I went to him, sir, I don't like this. Then what do you want? You are MTech, can you go to design section? Then I said, no, sir. If I go directly to design section, it will be an extension of this one. I want to work inside. Immediately he posted me to 5 crores corporate office building, ISRO corporate office building at Bengaluru. Now what I suggest, any postgraduate engineer, structural engineer, initial stage, he should work inside for at least minimum 1 year, so that he will understand the feeling in sites. Then he can switch over to design section. This is my suggestion, sir.
Great, sir.
Yes. Thank you.
Okay.
Hello. Yeah.
Yeah.
Who is it? Next.
Sir, Vijay Mahatesh.
Vijay Mahatesh Asundi, please go ahead.
Sir, I just want to continue the useful comments it's given by Mr. Madhav Kamath. Like we actually lack in detailing. Why don't we, over a period of time, why don't we arrange some technical session, something like this, where detailing can be taken as a detailed subject or topic. We can exchange our ideas, we can get some useful notes from experienced structural engineers like Surya Prakash sir. So sometimes we keep on telling the problems. Another thing is our responsibility to find a proper solution for that and solve it at one go.
Yeah, yeah. I think it's a good suggestion. I'm sure our program leader, Dr. Ajit Sabnis, will take a leaf out of this, and maybe one of the programs can be on detailing. If I remember right, one of the lectures in this series also is about detailing. We will definitely consider this and go for the series on detailing itself. Thank you. Next, anyone else? Before we move on to chat box.
Can I come back, please?
Who's this?
Madhav
Vijay.
Kamath.
Madhav Kamath. Please go ahead, Madhav.
I think Mr. Surya Prakash has already given a lecture some time ago on detailing. And he has even circulated his office document online. So I think people can refer to that. And I have recently downloaded from the internet a detailing manual published by the Institution of Structural Engineers, London. It is available on the net, third edition, published in, I think, 2006. Is available on internet. People can download it and study that. It's a very good document.
Okay.
Ranganath, can I come in?
Yeah, please, Ajit.
Yeah, the students and participants, I would request you, those who have put their questions in the chat box and then they have not been addressed by the speaker, kindly unmute yourself and then ask the question directly.
Yeah.
Because we may lose sight because there have been so many chats, things coming up, so popping up simultaneously. Kindly unmute yourself. Please tell your name and then ask the question. Thank you.
Yeah, hello, sir. May I proceed?
I have just seen one question by S.V. Prashant. He asked, how could a fresher start his career as a structural engineer? I always suggest graduates to start with detailing actually, and then go into the quantity survey and then pursue structural design next stage by stage. So a BTech graduate directly cannot become a structural engineer unless he passes through the test required. And so better way is to start with detailing. So that is my answer to SME Prashant. And can a base isolation system be assembled an existing building? We have seen the existing buildings being lifted. That is the case. We can also introduce the base isolation for the existing systems. And now anybody has questions, you can ask.
Good evening, sir. May I speak? May I proceed?
This is Sandeep Verma.
This is Syed Abdul Hai.
My request to everyone, please mute yourself and one at a time unmute and ask a question.
Good evening, Mr. Surya Prakash. This is my name is Shiva. I work in Dubai for last 30 years. I graduated from BITS Pilani in 1991. Okay. After that, I think I went too much into detailing. I am with the rebar company supplying rebar to a lot of sites here, like including Burj Khalifa. We have supplied all this. Now I have felt that I am getting too much away from this. It's a daily. I'm in charge of a factory which produces steel now, which processes rebar and deliver to the site. Actually, we do about 10,000 tons a month. But I have not pursued my MTech or anything like this. But since I have a passion for the designing and all these things, I am seeing some lectures out here and there and doing it. Is there any possibility for a aged person to do MTech? If you have any idea.
There are part-time courses like in Hyderabad, we have university which offers part-time tech. Actually, you can do that. And for education, there is no limit. You can study. and I'm a design engineer. And somebody asked me a question, what is the steel grade specification of a hangar which is constructed in minus 30-degree temperature? It is the same steel, high tensile steel, 350 grade, but we have used the temperature analysis for stresses, temperature variation, because the temperature variation is minus 32 plus 25 degrees. So we have designed for the temperature.
Can I speak, sir?
Yeah, please go ahead. Who is this?
Hello. Sir, this is Karthik Chari, assistant professor at
Sandeep Verma.
MR College, sir, Hyderabad.
Yeah, Mr. Karthik Chari, go ahead.
Sir, actually, I have doubts in detailing, sir. So exactly what is crank, what is hook, and what is development length? So it's a little bit confusing about these things, sir, in detailing.
See, crank is a sloped, bent up bar actually. This is the cranked bar. Okay, but I-456 and SP34 now discourages using the crank bar for the sake of utilizing in the shear design, because shear is not a phenomenon in one cross section. So it, it is very difficult to use the crank bar in the shear. So go for stirrups, number one. Number two is, what is a hook? You asked me. So hook is a bend for closing the stirrup, for example, which is given in SP34. It should have the 12D, is the length of the hook. And the next question you asked is the development length. For the development length, you have the formula for development length from the allowable stress in concrete and yield stress in the steel. So normally you will get 45D, 55D kind of length for the development length to develop the stress, designed stress. So that is the development length. This is Karthik.
Okay, thank you, sir. Sir, one more thing, curtailment, sir. Curtailment.
Hi, sir. Good evening.
Yeah.
Go ahead, Mr. Sandeep Verma. Sandeep Verma.
Hello? Yes, sir. Good evening.
Yeah. Go ahead.
Hi, sir. Do you have anything to say about shuttering work? Because many times shuttering is not taken care in heavy structures, heavy slabs, and that, because we do design, but on site shuttering is sometimes it is not taken proper care. Do you have any bad experience on this?
Yeah, definitely. So many collapses during construction due to inappropriate or undesigned formwork. I mentioned that in my one of the slides also, if you have seen. A structural engineer should understand the construction method and approve the formwork with allowing commencement of the formwork. And fortunately, we have a lot of engineered formwork available in our country. Aluminum formwork or Perry, all these formworks are available. Yeah. Abdul Hai, please mute the mic. They are getting the echo.
Sir.
Ask the question.
Yes, sir. Am I audible, sir?
Uttar, sir, mute your mic. Uttar. Yeah.
Yeah, go ahead. Who is this? Next.
Abdul Hai.
Yes, sir. Good evening. Thank you for the lecture, first of all. And then the question includes, when can we expect institutes like ACCE and other institute professionals that are related to civil engineering to go and push forward the government of India to bring more the practical aspects of engineering into our education system?
Oh, yeah.
Because on the one hand, we see lectures going on which are mainly focused on practicality of engineering, and then we have education system which is a little bit reluctant to accept and push forward the students. So when can we expect these institutes to put forward and make it compulsion for the students' benefit and for the society to take a step in this regard?
Yeah, I take your.
We see smart interest doing that.
We will work on it, Abdul, and thank you for your suggestion. Next, Mallikarjuna, please ask your question.
Surya Prakash ji, this is the answer to the Abdul's question. The new education policy and higher education aspect of it is addressing. There are a lot of changes going to happen from the next academic year in respect of vocational training, skill development, and the compulsory internship programs. It's already included. Yes. It's already embedded in the new education policy. So from the next year, it's going to be, I don't know which semester you are studying in, but it's going to will be mandatory. I think this is for the Abdul.
Yeah, I'll take some questions from the chat box. Somebody asked question when he designs.
Hello.
Hello. Yeah.
Hello. Good evening, sir. This is Sushama Remat, structural engineer.
Yeah.
Sir, I just wanted to know about the couplers that we use at the columns instead of lapping.
Yeah.
So I just whenever we have thicker bars like 25 mm and above, then we go for couplers. So I just want to know how safe it is and how frequently we can use it.
Yeah, you can use for beyond 16 mm dia couplers, mechanical couplers, and if it is planned properly before and tested. And we have been using for last more than 15 years these couplers in the project, and we didn't face any problem actually.
Can you use it even for beams, sir?
Yeah, beams, columns, and when we use couplers in columns, you can increase the maximum percentage of steel to 6%.
And what are the tests that are required, sir, when we use couplers? Because I've used it for
the
columns.
same tensile test you have to do after. Take the samples of the bars like we do the test of the steel. We have to test the couplers for the dia of the bars that we are using, so that we'll ensure that the performance is as per the design. Mainly
And,
the ductility.
Yes, sir. I don't know whether this question is relevant here or not. But what about the fee structure of the structural engineers now that we are talking?
It's a very relevant actually, madam. It's a very important question you're asking. Yeah, all structural engineers, if you are unified and stand on the percentage of cost, not the per square feet rate actually, it's very important. We must insist on 1 to 1.5% of the cost of structure, civil and structure. Never say structure alone, because a structural engineer cannot design structure in isolation. We have to design structure along with waterproofing, civil excavation, all that. So we must tell the clients, all of us should be on the same platform and demand the same fee structure. Then we'll all be happy.
Like architects have their Council of Architecture and they have their registration and they have their some fee structures. So I feel that personally that if we have some base where it helps everyone, whoever is practicing, and there will be good understanding amongst us as well when it comes.
In fact, I want to tell you the latest development. Bureau of Indian Standards is coming up with a professional services agreement to be incorporated in the IS code, pre-construction and post-construction. In fact, ACCE is part of that committee, and yesterday we attended that meeting, and it's going to come up. That will become the guiding document about the scope of work, scope of services. We should never talk about fee without having clarity about the scope of work and scope of services.
Yes. Thank you.
Thank you. Thank you.
Thank you, Sushama. Sorry, Prakash, you are... Any question? Any more questions?
Sir, Nilesh, I have one question.
Yeah, Nilesh.
Sir, I have done graduation in civil engineering and I am planning to do masters from Canadian University. Sir, will it be easy to move from Canada to India after my post graduation?
I suggest such personal questions you ask me through WhatsApp. But anyway, there is no bar. You can go to Canada, come back to India, but it will be little transit will be there, but you can come back, not at all. And I have a question in the chat box. Somebody asked, residential building complain always that designing more steel when they are designing as per the code. How to satisfy the client? We must say your build be safe, your building will be durable, I am designing as per and I am an editing. So we have to give to the clients. Next question is, should we go directly for structure or is it better to do any job after BTech? I always suggest undergraduates after graduation to work for 1 year before going for postgraduate. Understand the technical aspects of construction, and when you study structural engineering, you will be more complete person as a structural engineer. Yeah.
There is.
You can ask the question.
Who's it? Ashish?
Vadekar.
You have a question?
Ashish Vadekar.
Okay. Surya, there is one more question in the chat box. Simple one.
Yeah.
Sir, your suggestions to fresher structural engineer. A fresh graduate,
Yeah.
probably a postgraduate with structural engineering. What are your suggestions to him?
Always do the design manually. First structure you design manually. You draw the structural drawings with your hand, and then you will have the feel of the structure. Never get on to the computer directly. I am seeing many graduates start with I give the design and they start modeling and start. That is wrong actually. Even I tell my colleagues that they must design manually. It's very important. And you must visit the site during construction. Till you get the good experience of 3 to 5 years minimum, you cannot call yourself a structural engineer. A design engineer. That's it.
Yeah. There is another question in the chat box.
Hello.
Is there
Hello,
any
sir.
developments in unified registration for professional engineer? Surya Prakash, you are the right person to answer that.
Yeah. Also, there is a initiation of Indian Professional Engineers Council, but due to change in the education policy, they kept it in cold storage right now, the Ministry of Human Resources. And this actually to bring all engineers onto one platform. We should all fight for our rights and tell government that it's very important to have a unified registration of engineers across the country and make them accountable and responsible. So it's very important. It's a good question. We all should work. We need every engineer to come together and demand the government, the parliament to enact this act of IPEC bill.
Hello, sir.
Somebody asked me important
Hello,
question.
sir. I'm Ishwar.
AAC blocks. Ishwar, just a minute, please. I have seen a good question. What take on AAC block masonry cracks develop? This is another. I forgot to mention in my lecture. In fact, masonry is not a mason work. Masonry is a structure. Every engineer should design the masonry also. Particularly when we are using AAC kind of blocks, we must use the codal provision. There are 2 codes given design of the masonry, structural stability and all. So if you design, there won't be cracks in the AAC blocks. And design masonry. This is the question by Iren Dauda. I have been using AAC blocks for your information for the last 20 years, and I don't get cracks in my masonry because we design. So you must use the mullions and you must use bands to transfer the wind load or any deflection loads to the structure, main structure, columns and beams. So please use the mullions and bands, and the coefficients given 18D and all in masonry code will get modified with the AAC block. Please design the stability of the AAC blocks for to avoid cracks in the AAC blocks masonry. Yeah, now yes, Ishwar can ask.
Yes, sir. I am an undergraduate student. I am very much interested in the sustainable buildings, green energy buildings, zero energy building. So from a structural engineer point of view, what are the fields that I could study for, like materials and other things?
Actually, sustainability is a growing field, and Dr. Ajit Sabnis' doctorate is in sustainability. He developed certain methodologies, and we still have to get in the academics these sustainability courses actually. So you can study the Griha Green Rating System, ECBC code, and the IGBC code, USGBC. As an engineer, we must have the understanding of the embodied energy, and you can go through Ajit Sabni's lectures in the previous sustainability engineering series. So in there he would have given all the inputs. You can follow that.
Sir, where I could find those lectures?
YouTube
or
ACCE website.
Okay, sir. Thank you,
YouTube
sir.
channel and ACCE website.
I think we will take one last question if anyone wants to ask. Okay, Surya Prakash, I will end with
one question in the chat box. Important. Anything related to de-shuttering slabs and beams with respect to RCC? IS 456 has given clear guidelines for de-shuttering time, 7 days and 10 days for spans, with the prop in position, with the repropping. So every structural engineer should have the understanding of this terminology, prop in position. Prop in position is a shuttering system in which it is called prop head system. That means you can keep the prop in position and de-shutter. That means you are keeping the props for the main structural span to take the loads, but stripping can be done. So we have done the stripping of the slabs in 24 hours also with the prop in position system. So that is the de-shuttering system of slabs and beams. And we must study as a structural engineer the methodology of de-shuttering and methodology of de-propping and repropping, because the section control we have to do at the time of de-propping itself.
Okay, Surya Prakash.
Yeah.
One last question from the chat box. I think it's important that engineers know what the current status is and what is the actual meaning of professional engineer. This is Mohammed Imran, registered structural engineer. Recently, one of my known consultant received notice from Council of Architects for using name architect in similar way. Do we civil structural engineers have such rights regarding title and style, sir?
Yeah, at present, the title of engineer is not protected by any act of parliament, but the institution of engineers. If you are a member of institution of engineers, you can use the title of engineer. And institution of engineers is not a direct statute, but it is the only statute available. For engineers to be defined themselves as engineers, we have only 3 statutes in our country. One is the National Building Code, in which a structural engineer role and responsibility is defined, and competence also is defined for the engineer. So please refer to National Building Code Administrative Section. Number 2 is Institution of Engineers. Institution of Engineers is also formed by Royal Charter, but unfortunately, after independence, the Indian government has not recognized at that Royal Charter. So there are a lot of issues happening between Institution of Engineers, but still we can go to court with the Court of Law with the Institution of Engineers membership. Number 3 is the registration of structural engineers in urban local bodies. You can register and then you can call yourself an engineer. But other than that, we still don't have an act of parliament which recognizes the word engineer in our country. So we are all fighting for that. And in fact, the Indian Professional Engineers Council is still in the draft stage bill. So it has to be taken up by all engineers together, all associations. We have brought ACCE, and we have brought together 18 associations in our country, which are all dealing with engineers. We are working with MHRD to get this Indian Professional Engineers bill enacted. So let us hope it will happen at least in this decade. I have been working in the last 3 decades to make it happen. It's my dream as an engineer, because we'll be respected only if our constitution recognizes us as engineers.
Yeah, I would like to add to that, Surya Prakash. Mohammed Imran, As Mr. Surya Prakash just mentioned, bill has to be passed. An engineer's bill has to be passed in the parliament or in the Indian parliament. Only when the bill is passed, a council is going to be formed. Like what Mr. Surya Prakash said, IPEC, Indian Professional Engineer Council. The council is going to stipulate certain strictures. Only after that are we going to have the style and name of an engineer attached to us, just like what architects are doing. In fact, architects bill has been passed. It was passed in 1972, because of which their style and name is protected. I think that is the answer to your question. And we are waiting for the engineers bill to be passed in the parliament. We hope it happens very soon. And thank you all. It was a wonderful evening. We really appreciate and thank Mr. Surya Prakash for the great presentation he made. And it was an eye-opener for many of the students who are present here. And it was a great thing for us also, the practicing engineers. The experience of Mr. Surya Prakash was put in very simple words, and it was really great. Thank you very much, Mr. Surya Prakash. Now I request Mr. Dr. Ajit Sabnis to give some concluding remarks on today's presentation. With that, we'll be ending today's program.
No, there is nothing, no concluding remarks other than saying excellent as usual for the wonderful presentation, Surya Prakash ji. And I'm sure everybody has been benefited, and especially the students. All I request all the student participants, if you have any further doubts, you can mail your questions, send your questions or any queries to Association of Consulting Civil Engineers mail ID. And to some of those people have asked where the PPT will be available. As I said in the beginning, the PPT will be available, will be made available. The live presentation which Surya Prakash ji made, the speaker made, will be made available on YouTube. So you will have at least or two, and also on the ACCE website as told. So you will have a lot of presentations, a lot of interesting things. And this is only the first talk in the series. So all the 10 remaining talks are going to be equally beneficial to you also. Please tell your friends who have registered but not able to join. And I'm sure take benefit of these things, because ACCE is giving this a free opportunity to many of these things. And then please come prepared for the talk, because you know the topic well in advance, so that your questions can be very precise and then crisp, so that more questions can be taken. Thank you one and all, and also thank you so much Surya Prakash ji once again for that wonderful session. Thank you all the participants.
Thank you all.
Bye.